I want you to imagine being at the absolute top of your field, highly trained, decades of experience, flying a massive machine through the sky.
Right.
But then just a seemingly harmless desire to maybe make up some lost time. It starts this cascade of tiny, almost imperceptible errors. On December 20th, 1995, a single rushed keystroke in a commercial airline cockpit, literally just typing the letter R instead of RO, sent a Boeing 757 hurtling into the side of a mountain.
It's incredibly chilling.
I mean, think about it for a second. We are so conditioned to think of plane crashes as these dramatic, explosive mechanical failures, like an engine falls off or a wing snaps, right? A hydraulic line bursts.
Exactly, the machine breaking.
But today's deep dive is entirely different. We're digging into the documentation of a tragedy where the aircraft, well, it functioned flawlessly from takeoff to impact.
Which is, it is deeply unsettling precisely because the machine did exactly what it was told to do. The failure didn't happen in the engines. It actually happened in the interface between human psychology and cockpit technology.
Yeah, and we are pulling our insights today from a really incredible, albeit heartbreaking, 3D documentary from the YouTube channel Air Crash Investigation. It's titled, What Really Happened to American Airlines 965? And our mission today is to really understand how this happened.
Because it wasn't just one thing, right?
No, not at all. We are unpacking severe UI and UX design flaws that existed in mid-90s aviation software.
Okay.
And we're looking really closely at this psychological trap that pilots call get-there-itis.
Which, that term get-there-itis, it sounds so casual, almost like a mild cold or something.
Right, yeah.
But in high-stakes environments, it is a proven killer. It fundamentally alters how highly trained professionals calculate risk.
So to understand how that risk assessment completely broke down, you really need to picture the scene.
Yeah.
It is December 20th, 1995, 3 days before Christmas. We are talking about Flight 965 flying from Miami down to Cali, Colombia.
Yeah.
And this 757 is just packed. It's mostly Colombian immigrants, families with small children, carrying gifts, heading home for the holidays.
And up front in the cockpit, you have what any airline would consider an absolute dream team. You have Captain Nicholas Tafuri. He is 57 years old, an Air Force veteran, and he holds an astonishing 13,000 hours of total flight time.
Wow.
Yeah, he's been flying for American Airlines for 26 years. Sitting right next to him is First Officer Donald Williams, who is 39 years old, also ex-Air Force, with nearly 6,000 hours of flight time.
So they really know what they're doing.
Oh, completely. Both of these men had thousands of hours, specifically on the Boeing 757 and 767 airframes. They were absolute veterans. First Officer Williams was the pilot flying, meaning his hands were physically on the controls, while Captain Tafuri was the pilot monitoring, so he was handling radio communications and, crucially, the flight's computer programming.
Okay, wait, hold on, because
Okay.
I'm really trying to reconcile those credentials with the outcome here. We were talking about almost 19,000 hours of combined flight time between the two of them.
Right.
These guys are basically gods of the sky at this point in their careers. How does a crew with that much ingrained muscle memory, that much situational awareness, end up flying a perfectly healthy jet into a mountain?
Well, it begins with this slow, grinding accumulation of stress way before they even push back from the gate in Miami. The entire eastern seaboard of the United States had been just hammered by winter weather that day.
So everything's backed up.
Everything. Flights were delayed everywhere. Passengers connecting to Flight 965 were arriving late into Miami, so the airline held the plane at the gate to wait for them. And when they finally load everyone and push back, they are dumped right into the peak of the evening Christmas week rush. Dozens of heavy jets are backed up on the tarmac, just waiting for clearance.
So they're just sitting there burning fuel, watching the clock tick.
Hour after hour. By the time the wheels finally leave the runway in Miami, Flight 965 is nearly 2 hours behind schedule. And, in commercial aviation, a 2-hour delay isn't just an annoyance for the passengers, it threatens the entire operational schedule for the airline.
Right, because of crew rest regulations. Explain how that works mechanically for the airline's schedule. Like, why does arriving late tonight matter so much for tomorrow?
Well, by law, pilots and flight attendants, they must receive a mandatory uninterrupted rest period between duty shifts. It's usually around 10 hours minimum. So if Flight 965 arrives in Cali 2 hours late, say well past midnight, the crew's legal rest period shifts forward by 2 hours.
Okay.
That means the return flight they're supposed to fly the next morning has to be delayed to accommodate that rest.
Which means all the passengers on tomorrow morning's flight miss their connections back in Miami.
Exactly. The plane is late for its next leg, another crew might time out, and you get this massive, expensive snowball effect. We're talking tens of thousands of dollars in costs, rebooking fees, and just hundreds of furious holiday travelers.
Right.
And the captain knows all of this. He carries the weight of that operational efficiency right on his shoulders.
That paints a really stressful picture. And it's a feeling I think you, listening right now, can probably relate to on a smaller scale.
Oh, for sure.
Think about a time you were running incredibly late for a crucial job interview, or maybe trying to make it to the airport for your own flight. Your brain gets completely tunnel visioned on making up that lost time. You speed on the highway. You roll through a stop sign. You skip checking your blind spot because literally all your cognitive energy is just focused on the destination.
Right, exactly.
That is, get there, ATIS.
Yes, and in an aviation context, it subtly corrupts your decision-making tree. Instead of choosing the absolute safest option by default, a pilot suffering from get there ATIS starts subconsciously weighing options by how many minutes they will save.
But I struggle with this a bit. At 13,000 hours of flight time, shouldn't Captain Tafiri be totally immune to that? Shouldn't a veteran just look at the clock, shrug, and say, well, we're 2 hours late, it takes as long as it takes, the airline will just have to deal with it?
You'd think so, right? But it is completely counterintuitive. The documentary highlights that extreme expertise can actually make you more vulnerable to this specific trap.
Wait, really? More vulnerable?
Yeah. When you are a novice, a 2-hour delay terrifies you. You stick rigidly to the rulebook because you don't trust yourself to improvise. But when you have 13,000 hours, you have successfully navigated thousands of minor emergencies. You build this immense reinforced confidence in your ability to handle deviations.
Oh, I see.
You think, I have the mental bandwidth to take a shortcut because I've done this 100 times. It's overconfidence born from genuine competence.
Wow. Okay, so this veteran crew is flying south toward Colombia. They're hyper-focused on minimizing this delay and feeling really confident in their skills. And as they approach Cali, air traffic control offers them an opportunity to shave off some time. And this is really where the trap springs shut.
Yeah, so let's visualize the geography of Cali. The airport is situated in a long, narrow valley bordered by the towering peaks of the Andes Mountains. It essentially has one main runway running north to south. Flight 965 is approaching from the north. The standard absolute safest procedure is to fly the approach to runway 01.
Meaning they fly from north to south, right past the airport, do a big U-turn in the valley, and then land facing north.
Correct. And crucially, runway 01 is equipped with an ILS, an instrument landing system.
Let's define that for a second for the listener.
Mm-hmm.
How does an ILS actually help a pilot in the dark?
Think of an ILS as this invisible, highly precise slide made of radio frequencies. The equipment on the ground broadcasts a beam up into the sky. The plane's autopilot locks onto that beam, and it provides both lateral guidance, so keeping you perfectly lined up with the center of the runway, and vertical guidance, smoothly descending you at a perfect 3-degree angle right to the asphalt.
So it's super safe.
Highly automated and incredibly safe.
But to use that invisible slide, they have to fly past the airport and do that time-consuming U-turn.
Right. So as they are hurtling toward Cali, they're descending from cruising altitude. The approach controller radios them and asks if they want to go straight in and land on runway 19 instead. Runway 19 faces south. It's a straight shot, no U-turn required. They could shave critical minutes off their arrival time.
So they jump at it.
They accept it immediately. But runway 19 does not have an ILS. It only offers what's called a VOR-D-AIM approach. This is a non-precision approach.
What makes it non-precision? Like if there's no invisible radio slide, how do they actually know they aren't going to hit a mountain?
Mental math and very high cognitive load. Instead of the plane flying down a smooth beam, the pilots have to manually stair-step the aircraft down in the dark.
Oh, wow.
They have to constantly look at a dial showing their distance from a ground beacon, cross-reference that distance with a paper chart on their laps, and confirm, okay, at 15 miles out, we are allowed to be at 5,000 feet. At 10 miles out, we can drop to 4,000 feet. They have to manually adjust the plane's descent rate, mile by mile, in a mountainous valley at night.
So the workload just spiked exponentially.
Exponentially, yeah.
And because they were already pretty close to the airport when they accepted this shortcut, they're just completely rushed. They're scrambling to get the plane configured for a totally distant landing procedure.
And that rushing causes the first major procedural breakdown. They skip the approach briefing.
Which is supposed to be their ultimate safety net, right?
Exactly. In any multi-crew aircraft, whenever you change the flight plan, protocol dictates that you brief the new plan aloud. One pilot pulls out the paper chart and explicitly says to the other, "We are flying to this waypoint, crossing it at 10,000 feet, then turning to a heading of 190 degrees, and our absolute minimum safe altitude is this."
Right. It gets everyone on the same page.
It forces both brains to synchronize, it catches errors, but because they were practically on top of the airport, they felt they didn't have the time to talk it through.
They're essentially improvising at 300 miles an hour. And then comes the critical miscommunication with air traffic control. Because, I mean, this is 1995 in Colombia. The controller doesn't have a radar screen showing a little blip with Flight 965 on it, right?
No radar at all. The controller is completely blind. He relies entirely on the pilots to report their position over the radio as they fly over specific navigational waypoints. So the controller radios the crew and clears them to the Cali VOR, which is the radio beacon at the airport, but he says the clearance is via the Tuluá VOR.
Meaning, keep flying along your current route, pass over the town of Tuluá, and then continue straight down the valley to Cali.
Yes. But Captain Tafuri is task-saturated. He hears the words cleared to Cali and completely misinterprets the instruction. He thinks they are cleared to fly direct to the Cali beacon from their exact current position in the sky.
Oh, boy. And this is the moment that technology really starts to work against them. What physically happens when he inputs that into the computer?
Well, Captain Tafuri reaches down to the flight management computer, the FMC, which is basically this heavy-duty calculator with a keyboard between the two pilots. He selects the Cali VOR and he executes the direct-to-command.
Mechanically speaking, what does that specific button push do to the computer's logic?
The FMC is completely literal. When you tell it to go direct, it calculates a perfectly straight line from your current GPS coordinates to your destination. And to do that, it deletes everything else.
Wait, everything?
Everything. It deletes the Tuluá waypoint, it deletes the Rosso waypoint, it wipes out the entire pre-programmed mountain-free breadcrumb trail down the center of the valley.
It's like opening a massive computer script that has 50 lines of code perfectly designed to route your data safely, highlighting lines 10 through 40, and just hitting backspace. The safety net is just gone.
Yes, exactly. And they don't fully grasp that they've deleted their safe path yet. But a minute later, the blind air traffic controller calls them back. He wants to confirm they are flying the specific arrival route that keeps them safely in the valley, which requires them to report when they pass over a waypoint named Rosso.
Okay.
Captain Tafuri says, yes, we will report over Rosso. But then he looks at his screen and realizes the computer just erased Rosso.
So he has to put it back in, manually.
Yeah.
While flying a descending jet in a dark valley.
Yep. He looks down at his paper approach chart, which is illuminated by just a tiny little reading light, to find the identifier code for the Rosso beacon. On the paper chart, Rosso is identified by a single letter, R.
So he leans over to the FMC keyboard and he types the letter R.
And here we reach the fatal UI flaw. Think about how autocomplete works on your phone. You type SPR expecting Springfield, Illinois, but your phone assumes you want Springfield, Massachusetts because of some hidden algorithm. That is essentially what the FMC did.
Unbelievable.
The paper charts the pilots use and the digital database inside the FMC, they were both manufactured by the exact same company, Jeppesen. But for some inexplicable reason, they used different naming conventions.
Wait, the paper and the computer didn't match?
No. In the digital database, because Rosso shared a radio frequency with another beacon elsewhere in the country, you couldn't just pull it up with R. To get Rosso in the computer, you actually had to type RO.
So when Captain Tafuri typed a single R into the computer, what came up as the top result?
The computer pulled up a list of all waypoints starting with R, and because of the way the database indexed the coordinates, the very first result at the top of the list wasn't Rosso. It was a beacon called Romeo. And Romeo is located 130 miles to the east, near the city of Bogota.
Oh.
And because they were desperately rushing, because they skipped the approach briefing where they would have cross-checked the latitude and longitude coordinates, Captain Tafuri simply accepted the top autocomplete result. He hit execute.
The insight here is terrifying. I mean, we think of modern computers as these intelligent co-pilots that are there to catch our mistakes. But they aren't intelligent at all. They are flawlessly, brutally literal.
Yeah.
It doesn't look at the map and say, hey, Romeo is 130 miles in the wrong direction across M mountain range. You probably mean Rosso. It just says, command received, altering course.
Right, it's just diligently following its new programming. The autopilot gently banks the heavy 757 into a sharp left turn. It turns away from the safe valley, away from Cali, and aims the nose directly eastward into the pitch black night straight toward the jagged peaks of the Andes.
And the most chilling part of the documentary is that inside the cockpit, there's absolutely no sense of danger. The engines sound normal, the plane isn't shaking, they are totally enveloped in darkness, just watching their screens. How long does it take for them to realize the computer is taking them to the wrong city?
It takes a few critical minutes. The air traffic controller calls again, expecting them to be near Tuluá, and asks for their position. The crew looks at their navigation displays to figure out what to tell him, and they finally see it. The plane's heading indicator shows they are flying east. They are in a steep left bank.
And the cockpit voice recorder captures this moment of pure confusion. One of the pilots just mutters, where are we?
It is the ultimate nightmare scenario for an aviator. A total loss of situational awareness. They don't know where they are in the sky, and they don't know what the computer is doing. And tragically, while they are trying to figure this out, the plane has been doing exactly what they originally told it to do for the approach. It has been descending. They have now dropped below 10,000 feet. They are physically lower than the granite peaks surrounding them.
But they realize they turned left. They know Cali is south. So they try to intervene, right? They don't just sit there.
No, they take action. They switch the autopilot out of the pre-programmed navigation mode and put it into heading mode. This basically overrides the FMC and says, just fly whatever compass direction I dial into this knob. They dial in a right turn, physically steering the nose of the plane back toward the general direction of the valley.
So they think they've caught the error. They think they pulled the thread back together.
They do. The cockpit voice recorder shows them discussing the approach again. They are calmly running through their checklists. They are steadily descending in the dark, believing they are back on the safe path for runway 19.
Until the silence is violently shattered.
Yeah. The ground proximity warning system, the GPWS, the plane's radar altimeter senses the rapidly rising sheer rock face of the Andes directly beneath them. A mechanized, blaring voice fills the cockpit. Caution terrain. Terrain. Pull up. Pull up.
And this is where that 19,000 hours of experience kicks in. It's pure muscle memory at this point. They don't freeze. They instantly slam the thrust levers all the way forward to maximum power, and they pull back hard on the control yoke to force the nose up and climb over whatever is out there in the dark.
They pull back so aggressively that the stick shaker activates.
Explain what the stick shaker actually is, because it sounds absolutely terrifying.
It is a mechanical device built directly into the pilot's control column. When the plane's sensors detect that the nose is pitched up so high that the wings are about to lose their aerodynamic lift entirely, which is called a stall, a motor turns on and violently shakes the physical steering column in the pilot's hands. It is incredibly loud, and the physical vibration is really jarring. It is the airplane screaming at the pilot. If you pull back even one more millimeter, I will drop out of the sky.
Wow. So they're riding this invisible razor's edge in the pitch black. The engines are roaring at maximum power. The nose is pointed at the stars. The steering column is violently shaking their arms. And they're just praying the plane outclimbs the rock face.
But the aircraft isn't climbing fast enough. It is sluggish. It's really struggling to gain altitude. And this brings us to the final piece of the tragedy, the forgotten lever.
This is the part that is just agonizing to read about. What was holding the plane down?
Minutes earlier, when they first accepted that shortcut from ATC and realized they were too high, they needed to drop altitude fast. So the pilot deployed the speed brakes. These are large, heavy metal panels that physically pop up on the top surface of the wings.
Okay.
They intentionally disrupt the smooth flow of air over the wing. They create massive aerodynamic drag to slow the plane down and allow it to sink.
So to give you listening an image of what this means mechanically,
Yeah.
if the jet engines are pushing absolute maximum thrust to climb the mountain, but those huge metal panels are still sticking straight up on the winds, destroying the lift, it's like trying to accelerate your car up a steep, icy hill with the parking brake yanked all the way up. The engine is screaming, but the friction is holding you back.
That is exactly what is happening. The speed brakes are fighting the engines. They are literally killing the lift the wings desperately need to carry the 757 up and over the ridge.
But surely there is a warning system for that. If the pilots command maximum thrust, doesn't the computer automatically retract those panels, or at least flash a giant red warning?
In modern aircraft, yes. Many automatically stow the speed brakes when max thrust is applied, but not on this version of the 757. It required a manual retraction, and the UI of the cockpit failed them one last time. There was an indicator light, a small amber light on the center instrument panel, that simply meant the speed brakes were extended.
Just a small amber light.
Yeah, and in the sheer sensory overload of that moment, The blaring pull-up voice, the roaring engines, the violently shaking control column, the pitch-black night, that one little amber light went completely unnoticed by both veterans. They never pulled the lever to retract the speed brakes.
And the result is El Diluvio Mountain.
Flight 965 slammed into the steep, sloping terrain of the mountain at around 250 miles per hour. The aircraft disintegrated, sliding over the ridge and coming to rest in pieces on the other side. Out of 159 people on board, only 4 passengers and a dog survived the impact and the freezing night that followed. It remains the deadliest aviation disaster in Colombia's history.
What haunts me the most about reading the official investigation report is the margin. The margin between life and death here wasn't miles. It wasn't thousands of feet.
No. The investigation board calculated that the Boeing 757 failed to clear the mountain ridge by an estimated 100 to 200 feet.
100 feet. I mean, you could throw a baseball that far.
And the agonizing conclusion the investigators reached was this. If the pilots had simply noticed that amber light, if they had reached down and retracted those speed brakes the exact moment the GPWS alarm sounded, the aircraft's aerodynamic performance would have improved so drastically that they very likely would have cleared the mountain ridge safely. They would have flown right over the top of it.
It is just unbelievable. When you look at the whole picture, it wasn't one massive failure. It was this creeping, invisible cascade of tiny compromises. The intense pressure to just save some time and avoid a scheduling nightmare led to them skipping a crucial briefing. Skipping the briefing meant nobody caught the fact that the safe flight plan had been erased. The erased flight plan led to a rushed, single-letter typo on a digital menu. That typo silently pointed the autopilot at a mountain. And finally, a forgotten lever, missed in the panic of the moment, sealed their fate by a mere 100 feet.
It really forces a very uncomfortable reevaluation of how we view human error. It is incredibly easy to read a report like this, point the finger at Captain Tafori and First Officer Williams and say, well, they broke the rules, they skipped the briefing, they messed up. But the investigative board deliberately highlighted the phenomenon of get-there-itis because no professional is immune to it. The massive external pressures of modern commerce force all of us into making risk-based compromises every single day. The systems we design, whether it is an airplane cockpit, a medical dosing interface in a hospital, or a financial trading algorithm, they must account for the fact that humans under pressure will inevitably look for the fastest path.
Yeah.
And if that path is guarded by confusing UI, like a single letter pulling up a destination 102 miles away, disaster is just waiting for the right moment.
And that is exactly what I want you, listening to this, to reflect on right now. Think about your own life, your own profession. How often do you skip your version of a pre-flight briefing? How often do you skip a double check on a crucial contract, or ignore a minor warning notification on your computer, or bypass a standard security protocol just because you are feeling that crushing, overwhelming pressure to deliver on time?
We all do it.
We all do it. We justify it because we are experienced. We tell ourselves, I know what I'm doing. I have the bandwidth. I can cut this corner just this once. But Flight 965 shows us exactly how fragile that confidence really is when the systems around us are entirely literal.
To err is human, as the documentary notes. The tragedy is when our tools lack the resilience to catch those inevitable human errors.
Which leaves us with a lingering thought I want you to mull over today. We started this deep dive talking about the expectation of being at the absolute top of your field, sitting in the captain's chair, in total control of the machine. But think about our increasing reliance on automation. If technology, like a computer auto-populating your navigation route, or an AI writing your code, or a GPS steering your car, if it is designed to seamlessly make our jobs easier, at what point does it actually begin to erode our situational awareness? At what point does the pure convenience of the machine turn us into passive passengers in our own lives, rather than the active, critical commanders of our course? Next time you're rushing, next time you feel that heavy pull of get-there-itis, take a breath and ask yourself, are your hands actually on the controls, or are you just blindly hoping the autopilot knows the way?